this channel, welcome to this video, and today I'm gonna talk to you about something that I really like personally, and probably you too because you're watching this video, which is how can we insert virtual objects into your favorite picture. So this is really something really interesting, but surprisingly really challenging, because you can insert a virtual object into a scene. This is kind of okay, but the problem is how can you make it realistic? This is a really tough problem, and today I'm gonna show you a method that proposes an automatic solution for that. So it is really nice way to get some object you like, I don't know, some action figure, some monster that is placed into your scene, and then it looks really real, so you can make whatever you want with that. This is kind of creepy, but well, I let to you to do whatever you want with this technology, right? So make good use of it. So let's say we have this picture here, right? You have this picture of, I don't know, like kindergarten, something like that, and for whatever reason I want to insert a sphere on this. And well, I just take a 3D model of a sphere and I just place it in a picture. And well, you can see that it's not nice, right? It's not cool. It's not like it doesn't blend well with the scene. There's no like shading, there's no interaction with the scene. So what can we do about it? Well, I would say let's start thinking about where's the light in the scene. And you probably would say, well, looking at the shadows here, you can see there's some light coming from the top, right? So if I think about that, I can take a renderer engine like Blender, let's say, and say, okay, I have this light that comes from the top, and I'm gonna place it right there, and then I can re-render it, and boom, I have something like this. Well, it's way better, right? It's way better. There's a shading going on the sphere. There's a shadow being projected on the floor. Really nice result, right? So that's something we have to account for, right? We want something that does it automatically for us. Well, we need to understand that this is not simple, because this method has to take this picture and say, okay, if there's shadow here, there should be light coming from the top, right? So that's one part of the problem. Then there's another thing. Let's say I don't want this diffuse or opaque sphere. I want a glossy sphere, like a mirror sphere, right? So okay, if I take that light that we just said before and let it like there, and say, okay, that's the light we have in the scene, and ask Blender to render it, boom, this is what you're gonna get, which is pretty, again, unrealistic, right? Where is the reflection of the horse, of this wood thing here, on the floor, of everything else? What I really would like to have is something like this, right? Where you can see the green stuff on the floor, you can see the ceiling, you can see the light. So, damn, this is really hard to get. I mean, how can you know what is around the camera, even though like we can see there's something going on the scene, but how can we get like there's this light that comes from above, like really have to guess something like that? So basically that is really, I think you get the idea, this is a really hard problem, right? And if I go further with that, what we really want is not just to get a single light from the scene, right? We want to get the complete light coming from the entire scene. So imagine like we have this 360 picture of the scene around the picture where we took the picture, and we want basically to estimate all of this. So basically this is like a panoramic picture, and well, you have all these pixels to estimate, right? How can you do that? Well, for our happiness, there's this paper called GMLight, Lightning Estimation via Geometric Distribution Approximation. And I'm gonna explain to you in a high level so you understand the basic idea, not going into details. The details are in the paper, so if you're interested you can check that. And so what they propose, it's a really neat way to solve that. And as I mentioned before, since it's a real hard problem, what they propose is to make it in like 2 steps, and so simpler steps. So if I go back to the image we had before, this image of the horse, what we can have is or what we would like to have is something like this, right? So basically what is this? This is a 360-degree picture of the scene, or a panorama, a 360 panorama. So basically you can see it wrap around. This light here is this light here as well. So the left side of the picture, if you move around, it matches perfectly this side. So yeah, it's a 360 picture. So this is something that we would like to have. So with this information we can, well, if you're into rendering engines and stuff like that, you can use it to render what we saw before, like this nice glossy sphere with shadow and everything. So, well, it turns out to be really difficult to estimate all of this at once. Like, there are many pixels to estimate, so it's really hard. So what they propose? Well, they go in two steps, as I said earlier, and the way they do it is like this. Well, you have the image that you want to insert some object, right? And you know, like I just showed, it's part of something bigger. Let's say this panorama here, right? So what they propose is to first eliminate all the, let's say, unnecessary information or pixels in image, and just keep the light sources that are strong. Let's say in this case, like the light bulb and the window, those are the pixels that provide most light in the scene. So they are the ones that give you shadow and everything. So in this case, this kind of information would be enough for the rendering of the opaque sphere, right? The one I showed you before, this one. So if you just take that information, you can have a render pretty much like this. So it would be good enough. But so let's keep with this one right now, and actually what else I want to say is, like, this is really hard to predict. Like, there's a lot of pixels here. There's this whole bunch of black pixels, and there's white pixels here. I'm saying, like, in the house of millions of pixels. So this is really hard to get right. You have millions of numbers to estimate from this image here. Well, good luck. It's really hard. So what they propose is to make it smaller. So basically, what if you take this whole section of pixels here and turn it to a single pixel, right? So let's say you have to, 64 by 128 pixels, which is already quite small, and turn it to a 20 by 10 grid of pixels. So it's way easier, right? And they have it a funky way to represent that, a really interesting way, actually. Using Gaussians, projections, so they get something like this. So imagine that now you want to estimate this, but actually what you get is something like this, which is quite good, as I said, for the render of an opaque sphere. But, well, that's a first step what they propose. So, and then you wonder, okay, how do I go from this input image to this kind of interesting representation, right? And maybe if you're into computer vision these days, the answer is almost always the same. You go with a network. So in this case, they have a regression network that actually does a little bit more, but I'm not going to details this time. And it outputs something that some values that actually enable the creation of this image. So you have the light intensity, the ambient, which is basically what is a single color that can represent all this black region here. So basically it's the average of the entire image. And you have depth values too to get like you can place the lights in some distance also in the image. So, well, with this you have this representation, which is quite nice, but we can all agree that what we really want is something like that, right? How can we render that nice shiny glossy sphere if we have this representation? So what the author suggests of the paper is to take this representation that we have and also the input image, and guess what, we add again another network on that. And this network so takes the nice RGB image, it takes this representation here, it passes through some inner parts of a network, and magically it gets something like this. So yeah, don't be so excited it's not the results are not so like they're not so realistic, but they are incredibly real and good. So more like realistically speaking, this is the ground truth. So basically that's the absolute answer you want to have, and this is what the paper have or give us, which is pretty nice, pretty good. So here you can see some results from the paper that they show. So if you take this input image and then you have this intermediate representation, and then this is the final result that they show. So you can see like we see the light here, and it also well puts that on the final output. And like this line, this result is pretty interesting because well you have the input image, there's no light in the scene that you can see, but with their approach they can recover and say well there should be a light on the left, and if you see the real image it's true, so there is a light here on the left. And same thing happens here, there's no visible light on the crop on the input image, but their method was able to get this light on the right as the real one. So those are pretty exciting results. And to conclude, there are some examples of their method being used. So from this left image here, that's on the top right is what they predicted, and then you can insert this furniture here and have the nice shadow underneath. Also here you can have this fire extinguisher and have again the shadow projected on the floor. So well, those are pretty nice results that show how the method really works. So yeah, that's it what I have to you today. I hope you had a better understanding of how to insert an object. You can check, they have code on GitHub, and hopefully in the future this is gonna be something really easy to do and use, right? Thanks. If you like the video, just subscribe to the channel. I'm gonna post more videos on computer vision papers for now, and enjoy it.